Okay, we are live. Let's go ahead and go. So 11.4 is the Pythagorean Theorem. Greek guy, real important Greek guy. And his Pythagorean Theorem is really, really, really important. Up until just a few years ago, every carpenter, every roofer, or roofer if you're from Ohio or Boston, um, every carpenter, just about every handyman was well versed with the Pythagorean Theorem, because the Pythagorean Theorem really helps in getting things at a 90-degree angle. For example, when they built this room, you would hope that the corners are at 90 degrees. That's nice. You want them 90 degrees. Your house, most walls in a house, you want to be at 90 degrees. And if you know the Pythagorean Theorem, you can make sure that they're at 90 degrees. So there's a lot of practical application. I say up to a few years ago, because now they have electronic gadgets that do a lot of this stuff for you. But still, a lot of carpenters basically use the Pythagorean Theorem every day on the job. All right, well, to understand the Pythagorean Theorem, we first have to understand the aspects of a right triangle. Parts of a right triangle. And what you must be careful about is to understand that the Pythagorean Theorem is only for right triangles. It's got to be a right triangle for the Pythagorean Theorem to work, to be usable. It's really a formula. All right, so what is a right triangle? A right triangle is a triangle that has one right angle and then two acute angles. It's impossible for a triangle to have two right angles. You guys should have learned somewhere along the line that the three angles of a triangle together add up to how many degrees? 180. Good. So some of you still remember that. So if I used up 90 of them already and I have a second 90-degree angle, I've used up all 180 degrees. There's no degrees left for the third angle. It's an impossibility. You can't have a triangle with more than one right angle. But any right triangle does have one right angle, and it makes the other two angles acute. Anybody remember what an acute angle is? Jack? You had it right the first time. An acute angle is less than 90 degrees. Right, the other two, don't do this in your notes. A has to be less than 90, and B has to be less than 90. For example, don't write this. If A were 10, B would have to be 80, because all three have to add up to 180, right? If A were 40, then B would have to be 50, right? Because all three have to add up to 180, and we already have 90 right there. If A were 20, B would have to be 70, because all three have to add up to 180. All right, A and B are acute angles. All right, we like them, they're acute. All right, B, the three sides. All right, so let's get down here a little bit. When you talk about the three sides, one of the three sides is more important than the other two, and that is the longest side. A right triangle always has a longest side. And can somebody raise their hand and tell me the technical name for this longest side? Technical name. Nick? No, it's not obtuse. It's a side. Angles are obtuse. Sides are not obtuse, but good shot. Go ahead, Connor, go for it. Begins with an H. I'll help you out. It is the hypotenuse. All right, isn't that a fancy word? H-O-P. H-O-P. H-Y-P. Brother. H-Y-P-O-T. I was ahead of myself. E-N-U-S-E. H-Y-P-O-T. E-N-U-S-E. That's a mouthful. A lot of times we'll abbreviate and just say H-Y-P. If I ask you on a quiz or a test, what's the name of the longest side? Can you get away with abbreviating HYP? No, I want you to say hypotenuse, because I need to make sure you know what in the world it is. All right, but any other time you can just use HYP. That's not a problem. So take note. You don't need to do this. I'm just trying to focus you. We already said it's the longest side, right? The hypotenuse is the longest side. And it's also across from the right angle. The hypotenuse is always the longest side, It's always across from the right angle. When you guys get to geometry in 2 years, you're going to learn this theorem, that the longest side of a triangle is opposite the largest angle. The 90-degree angle for this triangle is the largest angle, therefore the largest side has to be across from the largest angle. And so hopefully you can clearly see that that makes side C the hypotenuse. And it does look the longest as well, doesn't it? Side C looks the longest, and side C is opposite the right angle. And again, please understand the right angle is right here, right? It involves those two sides go opposite. What do you hit? Side C. So it's important that you understand that, because we've got to know which side is the hypotenuse. It's the key to the formula. All right, and then third, I'm going to use my green here. The other two sides are called legs. You have two legs and a hypotenuse, or two ducks and a big fat hen, whichever you are privy to, all right? I always think of Mrs. Souza when I think of that song, because one time on a soul-winning bus, she was singing Two Ducks and a Big Fat Hen. She did a good job with it. All right, so let me pause a second here and see if I can get something to help us with the actual Pythagorean theorem. How many of you have seen The Wizard of Oz? The Wizard of Oz. All right. One of the three characters goes to quote the Pythagorean theorem. They actually mess it up, but they do go to quote it. Anybody know which character goes to quote the Pythagorean theorem? Nick? Tin Man. Is it the Tin Man? It is the Scarecrow. It is the Scarecrow. All right, so quiet please so we can hear. Let me get my volume high enough. Get rid of my fan, turn my speaker. This might be too loud, but we'll see. Here we go. Here, let me use my mouse over here. Oh, great. Smart Ink is at it again. You know Smart Ink. Every juice and animate creature that crawls on the earth or drinks from a slimy sea has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, little choppy, huh? And with no more brains than you have, but they have one thing you haven't got, a diploma. Therefore, by virtue of the authority, get ready, here it comes. By the University Committee Artem, e pluribus unum, I hereby confer upon you the honorary degree of PhD. PhD? Doctor of Ecology. Some of the square roots of any society, when I thought these triangles equal the square root of the remaining sides. Oh, John, I've got a brain. How can I ever... All right, so that's the Scarecrow. He was supposed to be doing the Pythagorean theorem. He was close. He said the square root of the sum of the sides of an isosceles triangle. Well, it's supposed to be a right triangle, and he really should have said the square root of the sum of the squares of the sides of a right triangle equals the square of the hypotenuse. All right, so again, I think I probably just messed it up a little as well. Let me be clear here. The sum of the squares of the sides of a right triangle equals the square of the hypotenuse. There we go. And so this should be c squared, and that's the Pythagorean theorem. And you've always got to keep track of where the hypotenuse is, and that's the c. The sum, the adding, of the squares, squaring the sides of a right triangle, equals the square, squaring of the hypotenuse. You see it? So watch again. Don't do this in your notes, but again, let me walk you through it. The sum of the squares of the sides of a right triangle equals the square of the hypotenuse. Do you see it? So again, he really was supposed to say right triangle, and he said isosceles triangle. I wonder how many people caught it when he said it. I really didn't even catch it either. You think he's just saying the right thing and you don't even think about it. But that's the Pythagorean theorem. It's a real important theorem. It comes up all the time in math. Again, as I said, carpenters use it. And so it's something you need to learn, something you should memorize. So how is the Pythagorean theorem used practically? Well, a couple different ways. Two ways we're going to use it. Two ways. The first way, we're going to use it to determine if a triangle is indeed a right triangle. Is a triangle indeed a right triangle? Now, carpenters use it to make sure that their angle is a right angle. If the sum of the squares of their sides equals the square of their hypotenuse, they know they have a right angle. And that's good. It's good to build things with right angles. If not, it's a mess. And you'd have a messy building if your walls weren't at 90 degrees. Well, we can use the Pythagorean theorem to verify if a triangle is a right triangle. So we have two examples. Here's our first example. We've got triangle ABC. And we don't know it's a right triangle. It looks like it, doesn't it? Looks like a right triangle, but looks can be deceiving. Hey, that angle C could be 89.1 degrees. Close, but would it be a right triangle? No. It could be 90.003 degrees. Still wouldn't be a right triangle. But the Pythagorean theorem will tell us whether or not it's a right triangle. Now, please note, you have to use the hypotenuse in C. And remember, the hypotenuse is the longest side, so which one's the hypotenuse? It's got to be the 34. So the 34 has to go in for C. And remember, you're squaring it, right? 34 is in for C, and we're squaring it. Uh-oh. Which one do we put in for A? Do we use the 16? Do we use the 30? Lions and tigers and bears. Oh, my. Is that Wizard of Oz too? I think it is. Yep. All right, we're really into the Wizard of Oz now. Which one do I use? I don't know. What do you do? Which one's A, 16 or 30? Which one? Which one? Are you sure it's a 16? Positive? I'm not positive. Oh, yeah. Which one is the A? 30. All right. Our triangle is ABC. Our triangle could be X, Y, Z. It could be anything. And in reality, the A and B's don't matter as long as you understand they're the legs. Technically, with us, the A, little a, is across from 30. But to be honest with you, as long as you use the legs on this side, you can interchange A and B. And then we got to square the 16. So hopefully you've already got your calculators out like we should always when we come to our pre-algebra class. Once we were past the fractions, we're using our calculators to help us out with time. Hopefully you found your square button already. Now, before you do anything on your calculator, hey, let's think about our equation. We're just going to head, there's no variables, so let's just go ahead and square everything. So 30 squared, hopefully your calculator said 900. 16 squared, what is that, 256? And anybody have 34 squared for me? What do you got, Kyle? I agree, 1,156. So let's add up the 900 and 256, and hey, what do you know? We got 1,156 equaling 1,156. Did the Pythagorean theorem work? It did. Hey, if it works, oh, it's supposed to be red, then it is a right triangle. Because it only works for right triangles. If the Pythagorean theorem works, if the left side equals the right side, it is a right triangle. We got a true equation, 1156 equaling 1156. This thing is a right triangle. Now, sometimes they won't show you the triangle. Oh, no. And we got to verify, is a triangle with these three sides a right triangle? Somebody raise their hand and tell me how I'd start this problem. John? Not yet. How do I start this problem? Jordan? Got to put the formula. Start with the formula. A squared plus B squared equals C squared. Also helps you to memorize the formula. You do need to memorize it. Okay, which side is the key side? Say it if you know it. Its name. What's the name of the key side? On three. 1, 2, 3. Hypotenuse. So you have to figure out which one is the hypotenuse. Somebody raise their hand and tell me which one. Blake? How in the world do you know that? But it wasn't listed last. It's the largest, right? And that's correct. And therefore the 22 has to go in for the C. It's got to, folks. Now again, which one do you put in for A and which one do you put in for B? It doesn't matter. It doesn't matter. I'll just go in order. I'll put the 15 first, square it. I'll put the 18 second, square it. And now it's all calculator from here, right? Punch it, brothers. Punch with care. Punch in the presence of the passengers. You guys didn't hear Zach's speech a couple years ago. He was also at Nationals last year. The group, court group, did part of it. All right, 15 squared is 2 1/4, 225. Who's got 18 squared for me? Raquel? 324. Who's got the 22 squared? Kaylin? 484. All right, so now when we add up the left side, oh, we're over. I got 549 does not equal 484, so this is a big no. Is it a right triangle? No. Because the Pythagorean theorem always works for a right triangle. Always works for a right triangle. So that's one way of using the Pythagorean theorem. Let's see if when I put in the sides it works. Now please, 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 the key to it all, the C has to be the hypotenuse, the longest side or the side across from the right triangle. All right, it's being temperamental, I got to tell you. Let's go to our second page here. It is glitching, huh? Come on, technology, help us out. Took forever. Oh, I probably went past because I clicked it a couple times, right? So let's see if we can get back there. And back there. All right. And back there. Third time's the charm. Don't touch it. Come on, Betsy. There we go. All right. Okay, so what's one way of using the Pythagorean theorem? Determine if it's a right triangle. The other way is to find the third side of a right triangle. Now for this one, it's got to be a right triangle. Find the third side of a right triangle. You know two of them. You need the third. So here's our example. We know two of the legs. We know the two legs. We know the 3 and the 4. We got to find the hypotenuse. Josh, how do you think I'm going to start? Awesome. Josh says, let's start with the formula. A squared plus B squared equals C squared. I concur. I hope you do too. Okay, in this one, again, the hypotenuse is the hypotenuse. So we're going to put in 3 for the A. Hey, if you want to make the A 4, that's okay. I'm going to put in 4 for the B. But again, if you want to switch them, it really does not matter. And then C is still C. Do you agree? So we have 3 squared plus 4 squared equals C squared. Hey, let me ask you something. Over the weekend, didn't we solve equations with the variable squared? Didn't we do that? Doesn't it make sense now that we're doing a problem like this involving the Pythagorean theorem? Because don't we want to solve for C? So what's my next step? What's my next step? Go for it, Blake. No, I don't need to do that yet. What's my next step, Jordan? I could, but look, when you're solving an equation with the variable squared, what do you do after the variable squared is isolated? What do you do after the variable squared is isolated? Alexandra? Take the square root of both sides. So I could add them up if I wanted to right now, but really I'm ready to take the square root of both sides. And by the way, pay attention right now. What do we always try not to forget to put in front of the square root symbol? Say it if you know it. Well, I got to tell you, on this one, we don't use plus minus because it's a different kind of problem. Has anyone ever seen a triangle where one of the sides were negative? No, not in normalcy. Here's the reality. Distance is always positive. You know what that ties into? The absolute value, right? The distance a number is away from zero. Distance is always positive. Therefore, we don't need to worry about the minus parts. Okay? So whenever you're finding the side of a triangle, we just worry about the positive part. So we don't need the plus minus. Okay, let's finish the problem here. We all know 3 squared is 9. We all know 4 squared is 16, correct? And we all learned that square roots undo squares, correct? So we have C on the right-hand side. And we also learned now to add up the two things inside before trying to take the square root. And we all know the square root of 25 is 5. And that's the value of the hypotenuse. Now, my time's already getting a little short, but let me show you what the carpenters do. On the right-hand side here where the C is, I'm going to put that 5 in. This is a common right triangle. It's called a 3, 4, 5 triangle. It's a right triangle. One side's 3, the other side's 4, and the other side's 5. Now, a carpenter can use 3 feet along one wall, 4 feet from the corner along the other wall, and then he'll measure with his tape if across from those marks is 5 feet. But usually carpenters like it better with bigger numbers because you can be more accurate. So they'll maybe double everything, 6, 8, 10. That's the same triangle. It's also a right triangle. It's double the size of a 3, 4, 5. Or they might use 9, 12, 3 times the amount, or 15. What they really use a lot is 5 times the amount, 15, 20, and 25. The bigger your measure, the more accurate that last piece is going to be, and they put that wall right at 90 degrees. They'll measure from where they want the corner of the wall to go, 20 feet one way, put a mark, 15 feet the other way, put a mark, and then they'll take their tape measure. They'll put it on one of the marks, stretch it out, and they'll move the movable wall until it exactly reaches 25 feet, and they'll say, nail it right there. And they'll nail their wall right there, and it'll be a perfect 90-degree angle thanks to Pythagoras. Okay, so it's used all the time. Guys building next door, they're using the Pythagorean Theorem. Guaranteed. All right, let's look at another problem here. Find the hypotenuse if the legs are 7 and 8. Well, here's a problem with no picture. So for time's sake, I got to go a little quicker here. We're going to start with our formula. A squared plus B squared equals C squared. Hey, it told us the legs are 7 and 8, so A is 7 and B is 8. Or if you really want to, you can make A 8 and B 7, and we're looking for the C, right? So it equals C squared. And you can see already you're ready to take the square root of both sides, right? All right, for time's sake, let me just tell you where this thing ends up. 7 squared is 49, 8 squared is 64, and the square root of C squared is C, right? So on this one, we end up with the square root of 113 equals C. Now that's an exact answer, but 113 is not a perfect square. So if you did it on your calculator is going to tell you 10 point something. Did anybody punch in 113? What'd you get? 10 point what? 10.6? Okay. So that would be a round off. Well, we're just going to leave it exact at square root of 113. All right, I got to get to the next type of problem because it's a little different when you're finding a leg. Little different when you're finding a leg. Hey, we start the same way, Pythagorean theorem, right? A squared plus B squared equals C squared. Agreed? Okay. In this case, the A is the variable. The B is the 6, so it's 6 squared. Agreed? And the C is the 10, so it's 10 squared. So you got a squared equals 6 squared. A squared plus 6 squared equals 10 squared. Okay, on this one, most people will simplify the squares and get 36 for 6 squared and get 100 for 10 squared. Do you see how this looks like a problem we did over the weekend? Right? We want to isolate the a squared, don't we? So somebody raise your hand and tell me what to do next. Person? So tell me what to add to both sides. All right, I'm going to add a negative 36 to both sides. I now have a squared equals 64. A squared equals 64. Somebody tell me what to do next. What's next? Come on, somebody. Cole? Correct. I'm going to take the square root of both sides. Because this problem involves distance, do I use the plus minus? No, only because it involves distance. Square root of a squared is a, and we all know the square root of 64 is 8. And we just found that side a is 8. 8, 8, 8. All right, let's see if we have time for the last problem. Oh no, we have an x. I'm shaking in my boots. Okay, we're going to start with the formula. A squared plus b squared equals c squared. Mr. Scarecrow for a right triangle, not an isosceles triangle. Where do I stick the x? Raquel? Anywhere? The a or the b, correct. I'll stick it in the front. Why not? I'll make it the a. But she's right, either the a or the b. Hey, what goes in for b? The 11 is the next thing listed. Do I put the 11 in for the b? No. The 11's the hypotenuse. The 5 has to be the b. And the 11 has to be the c. As long as you get the hypotenuse correct, you'll be okay. So again, most people prefer to square the things that can be squared right now. We got a 25. Who knows 11 squared? Say it if you know it. 121. See how we're right back to the same procedures over and over again once you learn them? All right, so what's next? Somebody tell me what to do next. Somebody that hasn't done anything yet. Somebody that hasn't answered the question. Go ahead, Lauren. Correct. We'll move that 25 by adding its opposite to both sides. Now we got x squared equals, be careful. What is that, a 96? Adriana, what do you want to do next? All right, we're going to take square root of both sides. Do I need my plus minus? No, because it is distance, right? It's distance. Antonio, what's the square root of x squared? Left side here, right here. What's the square root of x squared? It is x, I agree. And what do we do with the square root of 96? We're just going to leave it the square root of 96. If they wanted you to give a decimal round off, you'd punch it in your calculator and round off however they told you. If they don't tell you where to round it off, you go to one decimal place, but leave it exact if you can. All right. Hold on a second. Stop. You guys, I got to stop. If you guys are going to start packing up before I'm ready for you to pack up, I'm going to stop putting the problems on the bottom. You got it? Because I'm not done yet. Hang in there. So listen, you have to understand two key things. These are only for right triangles. You must memorize the formula. And remember, there's two ways we're going to use it. If it comes out true when we put in all the values, it's a right triangle. If not, it's not. And the other way is we can solve for a side. Keep those straight. You'll do both tonight. All right, now you can pack up.